Okay, so this is the graphical LCD that we will work on it today. We will learn how to connect it and program it with the Arduino. Okay, this is the one I already ordered. It's quite small, thin, and very nice graphical LCD. This is the part number. It is 3.3 volts. Okay, it got 28 pin with two backlights. This is the backlight pins, one here and one here, these two. Okay, as we can see here, the pin pitch is quite narrow and it's absolutely not breadboard friendly. So I already designed the breakout board. Okay, this is breakout board, and we will use it to open the pin out. Okay, so this one will be installed like this. Oops. This one will go here. Okay, and this one, it's easy now to hook it to any breadboard. Okay, so this is the LCD that we will use today. And this is the breakboard. Hello everyone, welcome again. So today in this tutorial we will learn how to work with the NHD-C128 pixel graphical LCD. Okay, this graphical LCD, as we can see here, it comes with this part number. Okay, it's come with this part number, and it's only 3.3 volts. It's super thin graphical LCD where it supports the COG, the chip on glass liquid crystal display. And let me highlight this. Yeah, as we said, it's 128 by 64 pixel. It's what else? Important for us, support 3.3 volt. Okay, and also support wide temperature range. Is very nice and good for industrial environments. Okay, and as we can see here, this is the mechanical drawings. Is super thin LCD, where you can see the LCD is only 2.9 mm in thickness, and the overall, including the backlight panel, might go up to 6.5 mm, which still considered very, very thin compared to another modules on the market. The LCD come in length of 77.5 about mm, and also the height is 52.4 mm or 52.5. okay, and yeah, it's come in white LED. The backlight, sorry, it's white in color, and the dot will appear as black. And the driver for this GLCD is based on ST7565R. Okay, this is the top view of the GLCD overall. As we can see here, the height is 52.4, 52.5, 77.5, and the width or the length of the GLCD, and also it's got 28 pin. Okay, 28 pin. This is for data and addresses and all the other interface. Here we will connect it to the Arduino, and this pin pitch is too narrow, so we cannot directly connect it to the breadboard. So I have already designed a breakout board to open this 28 to, I guess, 2.2, 2.1 pin pitch, so we can connect directly to the breadboard. And also here we can see is the anode and cathode for the backlight. Okay, so let's come here and enlarge this a bit. Okay, so this is the pin out for the the GLCD. As we can see here, it supports 28 I/O pins, including the power and all the needed signals. Okay, you see here the pin pitch is about 1.27, which is really not breadboard friendly. So now this one is quite different from the regular GLCD because it needs a lot of different signals or different components. For example, here need a lot of capacitor for the voltage booster circuit, and also got this quite different signal which called C86, which it's used to select the different MPU or microprocessor, whether 68 or 80. So for example, compared to this one, this graphic LCD is the regular NHD-C12864LZ-FSW-FBW, quite popular for beginners and very easy to use, just straightforward. You can see here it takes few signals, control signal. So a power signal take the ground VCC, and let's see, can we highlight here? Yes. So it take a ground VCC, and also take this for the backlight. Okay, I believe this VO for the what they call VO for the contrast. This register for control, read, write, and enable. Then these are for the data. Okay, and the data could be driven by either parallel by using 8-bit or only serial by using only, I believe, 2 or 3 bits using the serial interface. These can be selected. It can be selected or set using the PSP, whether we can set whether parallel or serial interface. And NC not connected, then here we have the reset and the Vout signal. But when we come to here, we can see like different components we still needed. So we will see now how to connect. I want to connect each pin of this GLCD in details. And by the way, I just want to mention that we will drive this. We will write the code in the Arduino. We will use the regular U8Glib. Is very famous and very popular, that support most of the graphic LCDs library. Okay, so we will see how later when we reach to the code development. Okay, so now first of all we come to the pin number 1. Let's see if I can take snapshot of these. Yeah, let's open this new, so I can draw directly on the, yeah, much better. So now pin, okay, so this pin number 1, now I cannot see pin, let's say, right? Okay, so pin number 1 is the chip select pin. Chip select pin will go and connect to the Arduino. Okay, I will connect here to the Arduino. Reset pin also will be connected to Arduino. This one also will connect to the Arduino. A0, this pin is responsible to determine, after we select the data or our information to here, to this pin, we will see this data that we already sent to the driver of the graphic LCD, whether it is instructions, a command, or is a data. This information here, it will go to the which register, the data register or the instruction or command register. This one also will go to the Arduino. Okay, now we come to, let's change the color, blue. We come to this signal, and these are very important. Please focus here, pay attention to here. These two, they are related to this signal. Okay, these two, they are related to this signal. No, sorry. Let's delete this. These two pins also related to this signal. How? First, we have to set the signal number 27, which is the C86. This signal, because now we are using Arduino, we are not using any 86 or 8080 processor. Okay, so we can hardwire this signal to either high if we want to manipulate that we are connecting to C86 processor, or we connect it to low if we want to tell the driver of the LCD that we are connecting to 8080 processor. So we have to choose either one, and according to here, because if you choose either one, then you come to here. Okay, so for example, if you choose already 86 equal to low, which is mean, then the driver will know that you are now talking to 88 processor. So then you have to work on this mode. Okay, but if you choose 86, you tie this to high VCC, which is 3.3 volt, then you have to use the other mode, the 68 mode. Okay, now let's see what are the 68 and 88 mode. The 68 mode, this is the 68 mode. Where's the cursor? Okay, the 68 mode, it uses only one signal, which is here, the read and write signal. It uses only this signal to change from read and write. Only this signal. You see, if you are on the 68 mode, we use the same pin to toggle whether it's read or write. If read, should be 1, if write, should be 0. And this one will be only enable active high if you are in 68 only, 6800. But if you are in 8080, no, this one will be write signal, active low. This one will be read signal, active low also. Okay, so if you choose this 8080, this is the 80 mode. This one will be write, this one will be read, and both of them active low. If you choose 6800, no, this one, the same signal here, the same signal for will be, it is the same one responsible for the read or write by toggle it high or low, same pin, and this one will be always high. This one will be always high because we want to enable it. So for me, I will choose 8080. So because 8080, and for me, for my purpose, I want to only what they call only write or display information on the LCD. So only write. So for sure, this one I want to write. So this one will be low because I want to write and I'm in 8080. So this one, it will be go low. This means connect this wire to the ground. And here I don't want to read because I want to write. So this one will be what will be high, because this one active low if you want to read, but I don't want to read, so I set it to high. This means this one will go to VCC, which is the 3.3 volts. Okay, and actually if you, even though you select, you, for example, now you want to go and select, let's change to red pin again. Let's say now you want to work, or no, don't make the red pin for the console signal. Say custom pen, which color is this? Customize, say green. Okay, let's say now you are choosing the 8600. Again, here you have to enable it, and enable is enable high. Okay, you see it's enable high. So you still need to bring this up to VCC. And here, again, I want to write to the VCC. So in this mode, in 68 mode, I want to write, not read, I want to write, so write again 0, so I still need to bring this down. So if you choose either one, 8080 or 8600, you still have to maintain these conditions. Okay, you still have to maintain these connections or conditions. Okay, let's continue. I'll go back to the red. Okay, so again, as we said here, these are the next 8-bit, or 8 signal. They are responsible for the data. They are bidirectional 8-bit. So if you use parallel, you can use all 8 of them. Otherwise, you can follow me and use only 2 signals, as am I doing, only these 2 signals, which is the bit number 6, this one, and bit number 7. We connect these two to Arduino, and the rest you just leave them floating. The rest no need, because we don't have much pin out or GPIO, so we can just save some GPIOs. Okay, so far we are okay, but now we have missed one important thing. Actually, you cannot arbitrarily choose or select, I want to go with serial or parallel, but the most important thing, you have to set this pin. Okay, this pin, you have to set it to choose whether you are go with the parallel or serial. And since here we said we are going to use the serial, so we have to set this pin to low. And set this pin to low is mean we connect it to ground. Okay. So now, how many signal we need for the Arduino? We have 1, 2, 3, 4, 5. 5 signals. Okay. Now we come to here. We come to the power. And let's change the power. Power yellow. Let's say yellow. Can we hide yellow? Okay. So now for the power, is it? Yeah. Okay. So now we come to VDD. VDD, you should go to maximum 3.3 volts. Okay. Ground, go to the ground. And now we have to connect these all capacitors according to this pin out, or the IOs, for the circuit called the voltage booster circuit. Okay. For example, here you have from the V out, you have a capacitor to VSS, which is to the ground. So I mean here there's a capacitor. Okay. Now here you have another capacitor. You connect 1 microfarad capacitor to minus cap 1. Minus cap 1 is N beneath. So I have here one, and connect another one here. Okay. There's a plus minus to cap 1. This is minus cap 1. Then connect here. If you see, this is the minus cap 1. Then you have to connect the positive of this cap to cap 3, which is the above one, this one, and also to cap 1. Cap 1 is N beneath. So you have another cap here connected to here. Okay, so how many cap we have? 1, 2, 3 capacitors so far. Okay, now this one done, this one done, this also done. Now we come here, connect 1 microfarad cap to cap 2. Again, we have, let's bring it here. We have another capacitor and go back to here. Okay, cap 2 also done. Now we have another one. These another 1, 2, 3, 4, 5 capacitors. The rest of the 5, they all to VSS. This mean all will be connected to the ground. So we have one here, capacitor, one here, another capacitor, one here, also capacitor here, and one here. 1, 2, 3, 4, and the last one. The last one here. These all will be connected to the ground. Okay, 5 capacitors connect to the ground, and I believe that's all. We see this one a bit headache, and you have to follow the IOs one by one, and there's some of the IO related to another IO. So yeah, another signals depend on another signal that you need to set. So most of all, I mean, you need to just follow these schematics, then you will be okay. Okay, we start again. These three, the first three will connect to the Arduino. We will see how we will declare in the library. Read and write and the enable is only follow the pin 27. Okay, it only follow pin 27. You set pin 27 first, then you choose this one. And again, actually this one you can choose either. Still, you maintain the same connection here. Then you set the PS according to your favorite, whether you need a serial or parallel. Then from here, if you're serial, you choose only 2 and ignore the rest. If parallel, you can take all. And then this is for the power supply, or not power supply, and the voltage booster circuit. The capacitor, you need to add them. And by the way, the capacitor will be in 1 microfarad cap, or 1 micro up to 2.2 micro. Okay, so I believe that's all for the schematics and the required hardware. Let's see what else we need to mention. Yeah, here as we say, we can see how it's connected, but this one again, this is for the MPU. We're not using MPU, we're using Arduino, so you have to follow the one I show you in the schematics just now. This is the part number and the driver number. This is very important. Also, you need to remember it later. We will select it in the library. And here just some operating voltages and also some input output levels, when to take high and low. This one all no need to worry about, because this all will be settled by the library. Okay guys, so let's go now to see how it looks like on the breadboard. I already soldered out the breakout board, and I will hook the circuit. And by the way, it's good to mention, I just remember now, because here, if you remember, you see, where is it? Supply voltage VDD, it's only support 3.3 volts. And also the IO, you see this one, sorry, the high-low level, it's also near to VDD, or the maximum voltage. So here, if you want to drive these signals, for example, 1, 2, 3, these 3, or even these 2, you cannot directly drive it from that, because the Arduino is 5 volt. So you cannot directly drive it from the 5 volt. So you need a voltage divider. Okay, because now let's say this is your Arduino. This is your Uno. The Uno actually is already got 5 volt or 3.3 volts. Okay, 3.3 volts, you can connect it to the VDD here, no problem. But the IOs, they are only outputting 5 volt. So how we will settle this? We will design a voltage divider. This is will go to the ground. and this will go to the GLCD. Okay, and this one will go to the I/O. Okay, voltage divider to drop the voltage from 5 volt up to 3 volts. Okay, I'll use a voltage divider. So the GLCD will see only the 5 volt, and the Arduino will maintain its work on the 5 volt. Okay, so now let's go and see how I will solder the hook on the breadboard. Then after this, we will drive the coding. Okay guys, so here I already soldered out the breakout board to the LCD and also solder out the pin header. Okay, and I connect the pin header to the breadboard. And as you can see here, sorry for the mess, but believe me, I follow exactly the schematics shown before that. Okay, here you can see this is the boost, what they call the voltage booster circuit capacitors. Okay, been connected already. These are the voltage dividers to convert from the 5 volt of the Arduino to 3.3 volt, and the 3 volt directly connect to the Arduino. If you can see here, I use the 3 volts. If it can zoom, okay. You see, this is the 3.3 volts. I connect directly to the to the main input or main VCC of the GLCD, and these are the other signals. Don't worry about this. This is the what I call a digital temperature sensor. Later I will make another video on it, but so far only this is the required connections. This is the voltage booster, voltage divider to convert from 5 volt to 3.3 volts. Here it is. Okay, so with this we are ready now to write the code. Let's go back to the computer and write the code for this circuit. Okay guys, so now we have reached to the software writing for our GLCD, graphical LCD. Okay, so now as I said before, I will not design any new code. We just use the simple provided example code. And here I'm using the U8Glib library. I will give you the link in the description where you will get this. Okay, so you can just install it in your or edit your environment, then you can use it. So you can see here I just use the example, one of the examples provided by the U8Glib, which is the graphic test. So after you load the graphic or open the graphic test, you will get this example. So from here we can see these libraries support a lot of the LCDs, and our LCD is here. This is the one, the the U8Glib and the NHD-C12864. And again, it takes 5 pins, as we said just now. Take clock, MOSI, chip select, A0, and the RST. So if you come here, these are our signals. Where is it? Yeah, let's put it like this. Yeah. So now with the clock, this is the clock. Let me highlight it. This is the clock signal. DP6. I connected to pin number 5 in the Arduino. Now MOSI, the master out slave in, for I collect this one, the DP7 SI, the serial data input, to pin number 9 in the Arduino. Chip select, here it is, the chip select, the first pin, I connected to pin number 8. A0, the third pin, this A0 I connected to pin number 7, and lastly the reset pin, the second one, the reset pin I connected to A3. And the rest of the schematics I just connected same as we discussed before. Okay, so here it is. This is the declaration of the object of our GLCD. And the rest of the code you just maintain, no need to modify. It's just a workable example. The only one thing I added is rotate the LCD screen by 180, so I can easy for me to read, because when I checked first time it was upside down. So I just rotated 180, and also I set the contrast, because this type of graphic LCD, the controller support digital contrast setting, not the manual analog one, where we use, if you remember, the other LCD, we use the potentiometer to set the contrast. This one is a digital. And that's all. Let's add some delay. Yeah, that's all. So let me connect the board with the schematics. Here we go, and hit upload. So hopefully everything will be fine. It takes some time to compile because it's a bit long script. Okay. Compiling. Everything is happy now. Downloading, sorry, uploading now. Okay, nice, done. Okay, beautiful. So now I can see my screen displaying the different graphic tests. So I will move to the second camera to show you the exact output on the graphical LCD.
Okay guys, so as we can see here, we power up the circuits already, and here is the output on the LCD. Nice, it's show all the testing patterns from the library. Okay, it's all the cycles. So with this, we are already successfully drive this unusual graphic LCD. Actually, I have such a lot of online tutorials and resources on this LCD, but I couldn't find any helpful information about it so far. And not easy to drive this because of the, as we say, the C68 and 8080 this pin. So after I figured out, I decided to share with you guys how to run this kind of unusual graphic LCD. Okay, so with this, we can now customize our code to display any required information or any shapes that we want on the LCD. And you can see it's quite nice and fast also. So thank you guys. Here we reached to the end of our tutorial today. I hope you have learned something new from this. Anything else, please let me know in the comment down below, and see you soon in the next project.